Number 54, summation as n goes from 1 to infinity, tangent of 1 over n, divide by square root of n. I would argue this is a more challenging problem. Okay, so even me, when I see it right away, I don't see any obvious technique that will most likely work. So let's go down our list of choices. Can we use the test for divergence here? If we take the limit as n goes to infinity of this guy, well, tangent of 1 over n as n gets bigger, goes to 0, right? So tangent of 0 is 0. Yeah? And then 1 over square root of n as n goes to infinity, that approaches 0 as well. So the test for divergence doesn't help us here. The limit is 0. Okay, so what's next? Integral test. This does not look like a nice integral to evaluate. So let's try to avoid if possible. It's not alternating series, right? So we can't use the alternating series test. How about the ratio test? Well, the algebra probably won't work out well because remember, ratio test is a sub n plus 1 divided by a sub n. Imagine doing tangent of 1 over n plus 1 divided by tangent of 1 over n. Even I don't know how to simplify that. I don't know. There might be trig identities that you can use to help simplify, but I don't remember those off the top of my head, especially on an exam where you're not given a list of trig identities. So avoid that if possible. How about the root test? This whole thing's not to the n power, so probably not that. So what are we left with? The comparison test or the integral test. Again, let's try to avoid the integral test if possible. So let's try the comparison test. Now, of course, the next challenging question is what do we compare it with? And do we do the direct comparison or the limit comparison? So I personally prefer the limit comparison. So you just got to pick something that looks close to this, hopefully. That's one technique. Or mathematically, if things can cancel, then that's another good choice. So that's how I picked my first candidate. It didn't work, this first candidate, but I'm just explaining my thought process, especially if you're new to this and you get intimidated on exams when you see something like this that's unfamiliar, you're not sure what to do, just use your experience to think things through. So I'm sharing my thought process of all this. Okay, so as I say, let's try to pick this series, 1 over n to the half, or 1 over square root of n. I know this is a p series with p equals half, which diverges because p is less than 1. And why do I pick this? Well, I'm thinking, can I cancel these? Maybe that will give me a clue. It actually doesn't work because limit as n goes to infinity, original guy, divided by the one we want to compare with. These two cancel, right? So you're left with tangent of 1 over n. Now, as n goes to infinity, 1 over n goes to 0. Tangent of 0 is 0. The limit comparison test, what did I just say? Limit comparison test here is powerless because it only works if this result is finite and positive. 0 is not positive. That's the problem here. So this particular series that we picked to compare with, do the limit comparison test with this guy, is not useful. Is there any way to get this positive? Is what I'm thinking. So I just thought that, well, I wasn't 100% sure for that, but I just thought, well, this is P is less than 1, right? What if I try the other way? P is greater than 1. So I picked n is 3 halves. This is 1.5, which is greater than 1. This is a convergent P series here. Okay, so now go through the motions of the limit comparison test. It's actually much better for this case. Okay, so dividing by 1 over n to the 3 halves, same thing as multiplying by n to the 3 halves, that's right here. And then I just did some algebra. These are, you can simplify by subtracting the powers. So that becomes 2 over 2, which is to the first power, okay? And this, so notice I just did algebra there. I didn't do any L'Hopital's rule or anything like that. Over here, notice it's 0 times infinity. So it's an indeterminate form that we're familiar with. We can change this n, this multiplying by n, to a dividing by 1 over n. And now it becomes 0 over 0. So you could use L'Hopital's rule here. Or you can do what I did. I just did change the variables. I let x be 1 over n. So I substituted. And as 1 over n, as n approaches infinity, 1 over n, which is x, approaches 0. So replace this n approaches infinity to x approaches 0. This you might recognize as very close to the special trig limit that you should have memorized. So I just rewrote it once more to make it very clear. Tangent is sine over cosine, yeah. So sine x over x, as x approaches 0, this is the special trig limit of 1. And then this piece over here, as x approaches 0, is 1 as well. So the limit is 1. So this works because this is finite and positive, and we know this guy converges. So by the limit comparison test, the original guy converges as well. Okay, if you have a different way of solving this, please feel free to share in the comments. But otherwise, this is honestly how I thought through it. It even took me 2 tries. So I would even, because I should say that this took me a couple tries, I would classify this as a more difficult type of problem.